Okay. So we have just a little bit of recap. We have entered into the zone of functional groups. What are functional groups? Which are a group of atom or a group of atoms which decide the reactivity of a particular organic compound or a hydrocarbon series. Okay, so functional groups. The first functional group that we studied was known as the halo group. Halo group. And the halo group is usually denoted by an X, and the hydrocarbon that you form is known as RX, right? And X can be in the form of chlorine, fluorine, bromine, iodine from the halogen family. I'm not writing much more. The next was the alcohols. Alcohol, which are known as the OH group. So the compound will be ROH, right? CH3, and I've discussed about methanol and ethanol in the right. Now we will see some class of compounds which are known as aldehyde. Okay. Then we will see ketones. Then we will see, understand these things. It will be very easy for you. Then we will see carboxylic acids. Carboxylic acids. After that, we will see a class of compound called esters. These are all which are mentioned in CBSE, esters. We'll see two more. One is amine, just for knowledge purpose, and we'll also see amide. Okay. Now, I'm making some colors. Aldehyde, ketone, carboxylic acid, esters, amine, amide. All are actually born from one person. Carbonyl group. So if you understand the carbonyl group properly, you will never forget all these things in life. Halo group is X and alcohol is hydroxy group or are known as ROH. Till this much, although we had studied about aldehyde and carboxylic acid also, I'll start them once again. So what I'm going to teach right now is not there in your syllabus, but if you understand it in this way, you will not forget. Okay. So let's understand what is known as the carbonyl group. This name you won't find in your textbook. Carbonyl group. Carbon has a valency of 4. So the 4 is met in this way. It will have a double bond with oxygen and 2 bonds open. This is called carbonyl group. Right? So this is something like maida or flour. From here we will make samosa, paratha, puri, gujia, pasta, pizza, everything. Just by small changes. Right? So our first one is aldehyde. The first one we will study is aldehyde. And aldehyde is formed when one valency is plugged by OH. One valency means, see this children, say this is one valency and this is 2, 1, 2. Any one valency is plugged by what? OH. So how does an aldehyde look like? Not OH, sorry. H. I'm so sorry, yeah. When it is plugged by H. Right? So how does it look like? It will have a carbonyl group with a double bond and you're filling an hydrogen out here. Right? So it looks like dash CHO. Dash CHO. So my hydrocarbon means I will have an alkyl chain. I hope you are understanding what is alkyl. Hydrocarbon is an alkane. From that alkane, take out one hydrogen. So it forms an alkyl. Simplest alkyl is CH3 or C2H5. That is what we study. But no one stops us from studying something like C17H35. That is also alkyl. Because in C17, what should be the alkane? 17 2s are 34 plus 2, 36. C17H34 is an alkane. 36 is an alkane. So alkyl is one hydrogen gone. C17H35. C15, then it should be H how many? 32. So one hydrogen gone, C15H31. That can also be an alkyl. So here the compound will be RCHO. RCHO is an aldehyde. RCHO is an aldehyde. So let's look at the aldehyde family. The first aldehyde will be, okay, when we say first aldehyde means the family of aldehydes with one carbon atom. But aldehyde is very stylish. Aldehyde brings one carbon atom in the functional group itself. If you see in alcohols, ROH, OH does not bring any carbon atom with it. X does not bring any carbon atom. But in all these families, which you're going to study now, they all have carbonyl group. So one carbon atom is by birth coming with it. So if you try to make the first series by putting CH3 here, you will land up into the second member of the series. This is also a homologous series. Why? Because it's the chain of aldehydes. Everyone will differ by a CH2 group and everyone will have similar chemical and physical properties. So here the first family is always CHO plugged with a hydrogen. Plugged with a hydrogen. And this name will be methanal. Methanal. Trivial name formaldehyde. Trivial name formaldehyde. Methanal or formaldehyde. The second member of this family will be known as CH3CHO, which is ethanal. Trivial name will be, CH3COOH. What is the acid? Ethanoic acid or acetic acid. So CH3C is a acetyl group. So this will be known as acetaldehyde. Acetaldehyde. Many, even in the previous days when IUPAC was not there, the name of this was also methyl aldehyde. Ethyl aldehyde. So there was, anyone is giving name to his choice. So IUPAC says, stop those nonsense. The name has to be in the way we say. So this is methanol, ethanol. So what should be propanol? Look, for propanol, what we will do? Just put one marigold flower. What is the marigold flower? CH2. CH3 has got one hand. CH2 has got two hands because one more hydrogen gone. And CH2 just goes and plugs there. So let's make propanol. See how propanol will be? CH3, CHO, and just put one more marigold flower, CH2. This actually satisfies your discussion again that two successive homologues differ with a CH2 group. What is the difference between this and this? Only a CH2 group. So this will be known as propanol. Propanol. Acha. One interesting observation in the case of aldehydes. One interesting observation in the case of aldehydes is that the aldehyde functional group will always come at the last. It will plug. CHO, na? See, it's plugging this side with hydrogen. No further combination is possible. So it will always come at last. So nobody writes ethanol 1 because ethanol has to be ethanol 1. Got it? Nobody writes propanol 1 because this has to be 1. This is the functional group. Is aldehyde clear, bacha? Any question on aldehyde? Carbonyl group and one is being plugged by hydrogen. Clear? Now we move to the next one, which is ketone. Ketone. So I will keep on rubbing this part. That makes the understanding go easy. So let's understand ketones. Ketone. In ketone, what we do, plug both 1 and 2 by alkyl groups. Plug both 1 and 2 by alkyl groups. Have you understood? So your structure will look like this. I bring an alkyl group R, C double bond O, and I will have another alkyl group called R dash. Clear? So this will be written something like RCO R dash. Propanone. CH3, CO, CH3. How many carbon atoms? 3 carbon atoms. 3 carbon atoms. So it will be called, 3 means prop and propane. See, 3 means it's like this. CH3, COCH3. So what is the name? Propane. E changes with 1 on. Propanone. You can't get ethanol. कैसे करोगे ethanol? Because ketone is C double bond O. I am a little teapot with 2 handles. If you bring 1 carbon here, 1 2 already there, इसको भी तो plug करना पड़ेगा ना? 1 more carbon, propanone. Sufficient, इतना जानना ही है. So ketones are class of compound. Anything which is ONE in any medicine name means has a ketone. So when you are having any sort of fungal infection, beta-methazone, in that cream it will be written. Ketone is there. Whenever you get a medicine next time, don't just read the name of the medicine and be happy. You should read the clinical name of that medicine also. Like, I hope you know, boys, you must be knowing it. When you fall down and all, you are given something called betadine. Have you seen betadine? Betadine is that brown color. Whenever somebody is being dressed for any injury, they will give betadine. Like, you have betadine as a medicine. You have another medicine of the same thing called pyodine. Pyodine and betadine are same. 2 different companies manufacture it. What is the composition? If you see the composition is povidone iodine. There's a ketone and iodine. Betadine is very interesting. Betadine, if you take 1%, then you can gargle. So the weather which is going to come now, Ganpati time, we will have a lot of throat infection. By the time you swallow, you get a pain, right? So you're advised to do betadine gargle. So when you go to any shop, in a medicine shop, and you say betadine dijiye, the person will ask you gargle or dressing. Because in gargle, betadine is 1 or 2%. In dressing, it will be 10%. You can't use the dressing betadine and start gargling unless you dilute it more. So next time you go downstairs to MedPlus, they will not be angry. And if anyone gets angry, say, Jaideep sir has told, can you show me one betadine gargle and betadine dressing? Don't buy, just read their composition. One will be less percentage, one will be more. The less is always for gargling. Got it? Okay, ketone समझ में आ गया? Okay, our next class of compound is carboxylic acids. And in grade, 11 and all, they will be teaching all these things at a huge space. The third for the day is carboxylic acid. Carboxylic acid. So in carboxylic acid, I will say plug either 1 or 2 by OH group. So it will become something like this, dash C double bond OH, which will look like dash COOH. And now you bring your alkyl member, single, ready to mingle, who is standing outside the pub, and it becomes RCOOH. Got it? These compounds are called carboxylic acid, and their names will end with oic acid. Oic acid. So let's look at the first member. First member is very stylish because already you are getting 1 carbon. Share what happened? Your camera is turned off. 1 carbon is coming along with the group itself, and the first member can have only 1 carbon atom. So you can't put a CH3 out here. If you put a CH3, it becomes CH3COOH. So we will put only a hydrogen. Okay, no issues. Hydrogen with it. Haku, HCOOH. And this is known as my first member, which is methanoic acid. Methanoic acid, also known as formic acid. And remember, ant bite. When an ant bites you, it will inject formic acid in your body. That's why when ants bite, it will itch. The coolest medicine that you can give yourself is, nobody has that at home nowadays, is the white Colgate. Not all those gel wala. Gel walas also have, the white Colgate is a very good base. Ant has injected what in your body? Acid. So it will itch on your body. So what you should have? Immediately Colgate, the Colgate which is white color. because Colgate is supposed to fight with the acid of your teeth and gums. So it has to be a base. So rub the Colgate on that ant bite. Or if you have raw papaya in your house as slices, just bite the raw papaya base. Or they will say when an ant bites, use mild soap and clean the infected area, because soap is a base. Got the idea now? But remember, when a wasp bites you, in Hindi we call it khatmal, wasp, then it is injecting a base in your body. But my problem always in my childhood, I ask, how do I get to know who bit me? Because if a wasp bites you, it's a base. At that time, you will see grandmothers and other people, they will bring keys, chabi, and they will rub the key on your body, because that is metal. Metal reacting with your body will produce some metal hydroxide, which is a base. So that's also, so sorry, acidic salt, not base, and it will try to clean up the top. So is this clear? Methanoic acid. Now let's look at the second acid, which we'll be studying very much in detail. It is known as CH3COOH, known as ethanoic acid, also present in vinegar in the name of acetic acid. So question comes, sir, in apple there is malic acid, lactic acid. These are organic acids. All these are some form of CH3COH. What are proteins? Amino acids. So they will have an amino group as well as an acid group. What about citric acid? Some COH. Salicylic acid, lactic acid. Again, any sort of paste, fungal creams or any sort of acne creams, they will always have lactic acid and salicylic acid common. Okay, carboxylic acid, have you understood? Yeah. Carboxylic acids will also come at the end. So we don't say ethanoic acid 1, because it has to be 1. Clear? So we are done with aldehydes, we are done with ketones, we are done with carboxylic acid. Let's see something called esters. Isko bhi padhna hai in our group, in our grade 10. Some reactions we will be studying them. Ester. It's not Easter, huh? Easter is the day when Christ rose back. This is Esther. Esther. So let's first understand what is esters. Esters are a special class of compounds which have fruity smell. Have you ever gone to a Karachi bakery? Once you enter the Karachi bakery, you get a smell. Every Karachi bakery, cake, biscuit, tutti frutti. That is ester. Esters will be present in all class of fruity compounds. There is a distinct smell in any bakery. Have you gone? The tutti frutti type of smell which happens, right? That is called an ester. So when let's say we have a mango, and this mango is right now raw. What is the taste of the mango? Sour. So the mango has a lot of acids in the form of carboxylic acids. And then this mango has to ripen. Then it will become sweet. So once it has ripened, where did the acids go? The acids got converted to ester. Such a reaction is called esterification. We will study that. And dishonest farmers and traders do not allow nature for this reaction to take place. They will not inject, they will add calcium carbide as a powder. Calcium carbide, when it comes in contact with moisture, will form a gas which is called ethine. And ethine introduces esterification. The mangoes which you see in the market, which are absolutely yellow, never buy them. And if you slice that mango, you will see the yellow pigmentation is happening in a concentric circle. Edges will be yellow, inside it will be still dull yellow. Once you eat it from this side, you will see sweet, suddenly it will be very sour. Very common thing done with Baganpalli mangoes. Got it? That's known as esterification. Esterification can be done with alcohol and acid also. Suppose you have any alcohol at home, spirit, and you have acetic acid. If you mix alcohol and acid, beautiful smell comes. What has been made? Ester has been made. So let's see what is ester. So in ester, we will be studying something called esterification. Esterification is the process in which acid converts itself to ester or ripening of fruits happen. Now, what is ester? In ester, we have got something. plug 1 with alkyl, plug 1 with alkyl, okay, and we will plug 2 with oxygen. You can do the other way also. You can do crisscross also. First understand. If I write it in Rama defeated Ravana in World War, you will write that also. Do you know, Esther? You don't know. So first understand. If I write wrong, you are writing wrong. First understand. Plug 1 with alkyl, plug 2 with oxygen. You can do the other way around also. That plug this one with oxygen. Let's plug. So I brought an alkyl, C double bond O, and the 2 has to be plugged with what, beta? Oxygen. How does oxygen look like? Oxygen has got a valency of 2. Oxygen itself will also come like this. So oxygen plugs here and opens another valency. Yes or no? That you will plug with another alkyl. So it will be known as RCOOR. And people confuse this a lot with ketone. Ketone is RCOR. This is RCOOR dash. See the difference with ketone? Ketone is both sides R. This is R, O, another R. So this is RCOOR dash. Got it? How do we name it? How do we name it? The alkyl group, now listen, don't write. The alkyl group which is attached to the oxygen earlier used to be known as alkoxy. This part will be named as earlier names, alkoxy. And this alkyl group plus this carbon will be something. Suppose it was CH3, this is C. That means how many C? 2 C's. This part will be named as alkanoate. But nowadays we name it as alkyl alkanoate. Sir, why did you then teach me this? So that in the exam you remember, alkyl is the one who is attached with oxygen. Alkanoate is the one which is on the other side, including the carbon. Let's see one product. CH3, C, double bond O, O, CH3. Can also be written as CH3, COO, CH3. Can we guess what will be its name? Trivial will be methoxy ethanoate. Alkyl group attached to oxygen is called alkoxy. And alkyl group with the carbon is called alkanoate. Who is attached with oxygen? CH3 is what group? Methyl group. So as per the new name, how will you name it? Methyl. Methyl. Who is on this side? Also methyl, but don't leave this 2 carbon atoms. So it is eth now. Methyl ethanoate. Alkyl alkanoate. Methyl ethanoate. Okay, let's see this name now. CH3, COO, C2H5. How do you name this? The one which is attached with oxygen will be called as ethyl. And on this side, how many carbon atoms? 2. So what will be its name? Ethanoate. So the name of this one will be, is it getting difficult? Samajh mein aaya ki nahi? Don't give me blank faces. Either you understand or you tell me. Otherwise, it will be difficult when the reaction will be written and they will ask you, predict which alcohol should be used to get this ester. 0 milega usme. If you have not understand, please spell out. Have you understood the naming of ester or not? Okay, first let us understand ester. Carbonyl group 1, 2. 1 will be plugged with an alkyl and 2 will be plugged with an oxygen. So how does it look like? R, C double bond O. And O will have another opening. Plug another alkyl group out there. They can be similar also. So my compound looks like RCOOR dash. How do I name it? One of the alkyl group will be attached with oxygen Another alkyl group will be attached with carbon. The one which is with the oxygen will be named as, this is trivial name, you focus on this one, will be named as alkyl. In trivial, we used to call it alkoxy. I find that easy. Coxy, oxy means I am the alkyl attached with the oxygen, so I became alkoxy. And the alkyl group attached with the carbon, including the carbon, forms the name alkanoate. So if these are 2 carbons here and 1, then we have 3 carbons. We will call it a propanoate. If we have CH3 and C, we have 2 carbons, ethanoate. So let's look at this example now. In this example, with the oxygen, I have a methyl group which is attached. So in trivial, I'll call it methoxy. In IUPAC, I'll call it methyl. Children get confused which one to call methyl. Therefore, that alkoxy is an easy way to understand. Oxygen के साथ जो लगा है उसको बोलते हैं alkyl. Who is attached with oxygen? Methyl group. So this is methyl. And who is attached with the carbon? Another methyl. But that methyl with the carbon is actually 2 carbons. So it will be alkanoate means ethanoate. Alkanoate is an alkyl. Alkyl and oate, alkanoate. So it will be ethanoate. So the name of this will be methyl ethanoate. Wait, hold on. Now let's look at this structure. With the oxygen, C2H5. C2H5 is ethyl. So this should be alkyl. Ethyl. And on this side, what do I have? 2 carbon atoms. Ethyl ethanoate. So this name is ethyl ethanoate. Okay, let's name this one. Let's name C3. 3 means, tell me the alkyl with C3. 3 2s are 6. 6 plus 2, 8, minus 1. C3, 8, 7. COO, C2H5. Let's see. Chal, Shreya, all others quiet. You will name this. Who is attached with oxygen? You may make a mistake. No worries. Who is attached with oxygen? How many carbon atoms? 2 carbon atoms. What is the alkyl name for 2 carbon atoms? 2 carbon atoms. Who is the hydrocarbon in alkane? Name the alkane member with 2 carbon atoms. Ab padh nahi rahe ho iska matlab. Ethane. If from ethane you snatch 1 hydrogen, it forms what? Ethyl. So C2H5 is ethyl. Is it that difficult? Ethane is C2H6. From C2H6 you took away. C2H6 is a stable compound. You took away 1 hydrogen, then I become what? C2H5, 1 valency opens up. And this has gone and attached with the oxygen. So this is the alkyl. And in this case, the alkyl is ethyl. Let's look at the other side. Who has attached with the COO group? Propyl. But you have to count this carbon also. So we are having 4 carbon. Yes, what should be the name? Butanoate. So this compound will be ethyl butanoate. Is it that difficult? Trivial name will be ethoxybutanoate. Beautiful. Alkoxy alkanoate. Ethoxybutanoate. थोड़ा आपको Chinto, next son should be Minto. Like that. You have to be predictable. Okay. Now I'll give you a name. You tell me the structure. Okay. Raghav, ready? I will give you a name. You tell me the structure. Butyl ethanoate. Name is butyl ethanoate. So break it first. Butyl. Butyl means this is the alkyl group. Alkyl attaches with oxygen. So ester is the COO. Butyl should come here. Butyl. Butane is what? C4H10. So it should be C4H9. And on this side, I should have 2 carbon atoms. One has already come. Another means ब्यूटाइल एथेनोएट। ज्यादा मुश्किल नहीं है। If you actually close your mind, then it becomes difficult. Otherwise, it's easy. Alkyl, alkanoate. Alkoxy, alkanoate. Same thing. Now it is easy. When you see that benzene ring, then you'll see stylish compound. Meta, para, 1-hydroxy, 2-para. Like that also names will come. This is done. Ester samajh mein aa gaya. Well, now later on we'll see reactions. These will all come up. So ester's gone. This actually closes your CBSE. But two more compounds we will see which are also from the carbonyl group. So आओ देख लेते हैं. Okay, one from the carbonyl group rather. Okay. C double bond O. If you plug it with a nitrogen and keep it open, if you plug it with a nitrogen, oh, so it's okay. If you plug one valency with nitrogen and keep the other open, this is called a amide link. Go back to grade 8. Nylon is a polyamide. Many amides joining together is called a polyamide. So this is amide. This is an amide link. Just for your knowledge. It's not there in grade 9. Grade 10, sorry. And we also said we'll understand what is an amine. Okay. Amine. This is amide. And let's see the amine. Amine means, do you know ammonia? What is ammonia? NH3. So ask ammonia. You have got 3 hydrogen. Take out 1 hydrogen and open 1 valency. So it forms something called, Aryesh is totally fed up. His face is like, what is this kachra? NH2. So you can bring a RNH2. This is called a amine. Amine. Proteins are amino acids. So it will have an amine group and it will have an acid group also. This is an amine. Next in 11, you will study what is a primary amine, what's a secondary amine, what's a tertiary amine. Clear? Before going to reactions, so this was all about functional groups. Ask yourself, do you understand what is a halo group? Do you understand what is alcohol? Do you understand what is aldehyde? So let's do it quickly. Ekdam. Fastest finger first. Rapid fire. Halo, RX. Alcohol, ROH. Aldehyde, RCHO. Ketones, RCOR-. Carboxylic acid, RCO. And esters, RCOOR-. Amines, RNH2. Amide, RCON. But not required. ठीक है, आगे चले. Okay, let's come to, before going to our reactions, this is all about the introduction of all the characters. Now our next part of the chapter will be, we'll see some reactions of hydrocarbons, some characteristic reactions of alcohols, some characteristic reactions of acids. And in there, the CBSE as a board is very good. They have just picked one alcohol called ethanol and one acid called acetic acid. And whenever you study reactions of alcohol, you will only study ethanol reactions and acetic acid reactions. Alkane reactions are very, very easy. But before diving to that part, after that, we have soaps and detergent, which is just like Rattofy, everything done. Let's see one interesting thing called benzene. Benzene. You know, if you go to countries, like if you go to the Middle East countries and all, there people don't call diesel. Aapko diesel bolne ki aadat hai na? If you drive in Iran, diesel is known as benzene. Benzene. Okay. Benzene is very interesting. Benzene's formula is C6H6. You should see this. Benzene is a cyclo compound. Now see, and the structure of benzene is one of the most interesting things. C, 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 C. It has a hexagonal structure. How many carbon atoms, beta? 6 carbon atoms have been done. Got it? Benzene is a compound whose reactions were known. Benzene study was done, but benzene structure was, nobody could find the structure of benzene for a long time. Very interesting. But people were using benzene left, right, and center. Benzene structure was given by a person whose name was Kekulé. And he dreamt of this structure. Sapne mein dekha tha. He saw a lot of snakes had tangled on him, and from there he came out with this structure. Now you'll see why this structure is so interesting. How many hydrogens? 6 hydrogens. The 6 hydrogens are placed like this: H, 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 H. Sir, why did you write HC and CH? Just to show that the bonding is between carbon and carbon. Have we made the compound stable? Not exactly. Look at this carbon. It has a valency of how much? 4. So what is the valency? 1, 2, 3. What about this valency? 1, 2, 3. What about this valency? 1, 2, 3. Or 3, 3, 4th is not yet satisfied. Allow me to do one jugglery out here before we go to benzene structure. I'll just clone this and I'll keep one more structure out here. Now the best thing that Kekulé gave, okay? The best thing that Kekulé gave. So for that, let me also bring this fellow a little bit this side and clone it once again and bring it here. Now see what Kekulé said. Kekulé said that benzene has got alternate double bonds. Beautiful structure. See the valency of this carbon now. 1, 2, 3, 4, satisfied. Look at this. 1, 2, 3, 4, satisfied. Look at this. 1, 2, 3, 4, satisfied. Look at this. 1, 2, 3, 4. 1, 2, 3, 4, satisfied. Then somebody said, oh my dear, the structure can be this also. Just see the valencies now. 1, 2, 3, 4 satisfied. 1, 2, 3, 4. Which is the structure of benzene? This phenomenon is known as resonance. ये भी आप पढ़ोगे in grade 11. Have you played this game with kiddos? Catch the fish. Where is the fish, right or left? Sir, it is at right also, it is at left also. How many fish? Only one fish. Fish can come right, fish can go left. So these structures are known as resonant hybrids. So somebody says, end of the day, tell me, sir, is it Sonu or Monu? Both are valid. This is the structure of benzene finally. It means the double bond is keeping on rotating. This yellows are rotating into alternate positions. So whenever in higher grade chemistry book, you see any compound which is shown like this, the benzene ring is out there. Understood? Have you cleaned your bathroom with something called phenyl? Phenyl is also known as phenol. Dettol. Dettol contains phenol. Phenol, when it is 1%, can be used as antiseptic. Dettol can be used as antiseptic to do aftershave and put. More than 1%, if it is 5 to 10, it becomes disinfectant. At that time with Dettol, you are supposed to mop the floor. Very stylish compound. Dettol has got a compound called chloroxylenol. Phenol. What is phenol? Phenol is take out one hydrogen and bring an OH group out here. This is called phenol. आप पढ़ते थे ना, coal tar is used to manufacture toluene. Remember? Toluene is the benzene ring with the CH3, means one hydrogen knocked out and the alkyl is come here. This is another branch of organic chemistry which you'll study in 11 called aromatic compounds. Compounds which are ring compounds are called aromatic. Aroma. All sorts of perfumes, all sorts of deo sprays have all these sort of compounds. Phenyl has a smell with which you clean your bathroom. It has a smell. Dettol has a smell. Savlon has a smell. So these are all aromatic compounds. What are we studying? Aliphatic compounds, straight chain. This is not a part of your grade 10. I will not teach it in the next part. This is just for your interest. You should know what is benzene. Benzene structure was given by Kekulé and he dreamt of it. This is the only compound whose structure came much, much later than the product when it was used and its properties were studied. And benzene is the major component in diesel. Octane is the major component in petrol. That's why in foreign countries they say octane 91. Open any Honda City's petrol lid, it will be written use fuel 91, means octane 91. That is 91% should be octane in that. ठीक है, हो गया? चले अभी रिएक्शंस में, इसको हम बोलते हैं टोलुइन, इसको बोलते हैं फिनॉल. Again, toluene and phenol are trivial names, not IUPAC names. Acha, there should be something which should also be known as benzoic acid. In senior classes, you will study benzoic acid. Benzoic acid. Benzene group attached with acid. Benzoic acid means the carbon is there, the hydrogen has been knocked out. This is an aromatic acid. Okay?
So all of these have an aroma?
Yeah, all aromatic compounds. Anything which has got a benzene ring has to have aroma. Has to have aroma. That's why they are called aromatic compounds. 100%. Deosprays. Then anything, aroma means only the ones that you like. That doesn't mean anything which has got a pungent smell. Coal tar, that is also aromatic. That smell you don't like, that's a different thing. Did you get it? Aroma is aroma. Generally in its literature, likable odor is called aroma. So anything which has aroma, all deosprays, all perfumes, and in perfumes everybody is using a base which is a methylated spirit. That is the base. The composition is all about designing this or aromatic thing. That's why perfumes like Cool Water, why do they cost so much? The formula is hidden. And now you get what you call copy perfumes also. I don't know whether you have seen in Instagram reels. Cool Water 6000, लीजिए हमारा 600 रुपए में. वही smell. Those are copy perfumes. Even that also needs an industry. Okay? Then car perfumes, all of this. Okay, so we go into our first class of reactions. Now we are all done. So we will be studying hydrocarbons. And we will see hydrocarbons are beta of two types, right? Sat, unsat. And we will see reactions for both. The first reaction that we are going to see is known as substitution reaction. Substitution reaction. Substitution reaction is itself 75% of a chapter. Okay. So what are substitution reactions? A reaction in which a hydrogen will be substituted out from an alkane. Understand first. Understand. This section will study reactions of hydrocarbon. Hydrocarbons can be sat or unsat. In sat, we have got alkanes. In unsat, we have got alkenes and alkynes. The way CBSE will teach you this part is they will teach you some unique reactions. Those reactions may be applicable to both or to one family specifically. Right now, what am I studying? Substitution reaction. This reaction we will study only for alkanes. Okay. Alkanes, another name is paraffins. Just like you Gen Z kiddos type. Oh, we don't like to mix up with anyone. We love to be snobs. We don't talk. Even teacher Jerry explains, we make our face as if nothing. Do you nod your head? No, why should we? Unreactive students. Neither they have agony, nor they have happiness, nor they have frustration. Praise them, abuse them, hate them. No reaction. Will the teacher like them? No. Does the chemist like them? No. Paraffins. Para means less. Affins means affinity. Affinity means affinity for anyone. That means in other ways, these are less reactive. No chemist will like it. ये कोई काम का ही नहीं है. We got one बच्चा. Yes, the बच्चा is scoring 90%. ना हंसता है, ना बात करता है. Talk IPL, no reaction. Talk football, no reaction. Talk girls, no reaction. Talk about cricket, no reaction. Nothing, no reaction. तो बच्चा को क्या बोलेंगे? Paraffin. So we have to substitute something out of him. So you have to get the snob character out of him. So let's get the snob character out of him. So here what we take methane and we will react it with chlorine. I told you this reaction. This happens in sunlight and gives you a product called CH3Cl and HCl. So what did you do? There's a substitution. Hydrogen was substituted by chlorine. That's why this is known as a substitution reaction. Substitution reactions are characteristic reactions of alkane. But again, sir, you said they don't react. Then how did you get this reaction done? Very difficult, very, very controlled environment. But once this has formed, Vakul is born. He will talk, he will do mischief, everything he will do apart from study. You got it? So this is our Vakul. And this was somewhat like Amish. The day he needed a pen also, he didn't ask Veda, but he was asking me. I don't react. So this reaction, remember, it's called chlorination of methane and you form what? Chloromethane. This sunlight is very important. This reaction only happens in the presence of sunlight. And further steps I showed you. After this, the next set of reaction will happen. This one will react with another molecule of chlorine, will form CH2, Cl2 and another HCl. Dichloromethane. This one will react with another molecule of methane, CH, Cl3 plus HCl. This compound you should know, this is known as chloroform. The one that is used as a anesthetic agent. How many of you have been given anesthesia so far in life? You have had? Good. Beautiful feeling. The moment they will give you anesthesia, some mild smell, and you will actually talk nonsense. And by talking nonsense, suddenly you will become quiet. You love to talk more at that time. Therefore, whenever you are in of anesthesia or out of anesthesia, don't speak. You might reveal a lot of your secrets. You hallucinate at that moment. You'll say, you बहुत कुछ बात करते रहोगे. You know, doctor, yeah, I do that, yeah. Try to sleep, yeah. Take narcotic test में तो वही होता है ना. They'll drowse you and then ask you. Your brain thinking power goes off and you'll be answering straight questions and without thinking. Where were you on 26th night? दृश्यम देखा ना. 17 की रात को हम सत्संग गए थे, फिर पाव भाजी खाए थे, फिर सिनेमा देखा था, फिर देखा था. ठीक है? So substitution reaction is known. Let's see the next class of reaction. Okay? Next class is again important. That is known as combustion reactions. Combustion reactions. Now in combustion reaction, this is common for hydrocarbons. This is common for hydrocarbons. So if you write it on a holistic way, hydrocarbons will undergo combustion. That is, they will burn with oxygen, produce carbon dioxide, and then water vapor, and lots of heat. Hydrocarbons are very good fuel. This is the standard skeletal reaction. Now go back to chapter number 1 when we were studying what? Balancing. At that time, I used to give you reactions out of my head. Just like that, balance. I used to pick up any alkane because for me, the calculation is known. Suppose octane. Octane will be 18, 16, 18. C8H18 plus O2, CO2 plus H2O plus heat. Balance the equation. Any hydrocarbon, whether it is an alkane or an alkene or an alkyne, will react with oxygen to produce carbon dioxide, but there is a slight story in it. Have you understood? Now in these hydrocarbons, we will first see the class of saturated one, which is alkane. Alkanes will burn with oxygen straight away and give you CO2 plus H2O plus heat. You don't believe it? Then the guys who are at Bombay and Delhi, they burn PNG, pipe natural gas, so they are burning CH4. You, me in Hyderabad, we are burning C4H10, we are burning butane. And people in America are burning propane, C3H8. All of them will burn with oxygen. Acha. Have you ever gone to kitchen where your mom has put something on low flame and the kitchen light is switched off? Some rice or some egg is boiling. What do you see the color of the flame? Blue. Alkanes will always burn with the ambient oxygen. What is ambient oxygen? Oxygen that is present in the ambient condition, atmospheric condition. This oxygen is sufficient and they will always undergo complete combustion and they will burn with blue flame. Blue flame. Have you understood? Acha, you have a test tomorrow and there is no power in your house. Can you read by the kitchen gas? Study by that kitchen gas? No. Because the kitchen gas is giving you a blue flame, that means you're getting heat. So this flame is actually dissipating energy in the form of light or heat. When your mom is cooking using either of this fuel, the energy component in the form of heat is more. So illumination is less. In the kitchen, if the gas is on, then how to know that the gas that is being supplied to your house is very pure? The gas should be, LPG should be absolutely blue in color, coral blue. But you know, sir, in my house, between that blue color gas, suddenly some tick red sparkles come out. Your burner is dirty. Or there are carbon deposits in your burner. Or something you must have cooked which has spilled over and that spill component is now burning. The LPG flame should be beautiful blue. Blue. Blue means complete combustion. Will there be any soot left? Soot. You understand? Soot? No soot. That's why cooking in LPG is a very cleaner fuel. Understood? And the energy that you will be getting, this heat, I should use the word energy. The energy will be dissipated maximum in the form of heat. Got it? Let's take a Diwali wala ardan diya and burn it with desi ghee. Ghee is saturated fat. Or let's burn it with sunflower oil or sesame oil, unsaturated fat. In that case, can you study with that diya? Yes. Diya produces sufficient light. Can you make khichdi with diya? No. Because the energy is coming out in the form of light, that is incomplete combustion. So the diya will have lot of kajal in it and soot formation will take place. Incomplete combustion. So our next thing comes up that if the hydrocarbon is an alkene or it is an alkyne, the ambient oxygen is not sufficient for it to burn completely. It will burn, but it will burn with a yellow or a reddish flame, reddish, and it will have a sooty flame. Sooty flame. Sooty flame. एक काला होके निकलेगा. समझ में आ रहा है? But interesting thing is welding. What is welding? You will have two pieces which you will melt and you will join them. That means you have to produce a lot of heat. So this one should melt, this one should melt, melting, and they get joined. Weldings are of many types, out of which one welding is known as gas welding. Achha, children, don't mix it up with the AC guy who comes to your house. That is brazing. That's not welding, that's brazing. Gas welding. In gas welding, what do we have? We will usually have two types of cylinders. So this welding is known as oxyacetylene. Oxyacetylene welding. Acetylene means ethine. Trivial name. Ethine means, what is the formula? 2 carbon, C2, H2. And on this side, so one oxygen cylinder will be oxygen, one will be C2H2. Both the pipes will come out and will hit the torch. This is your torch. And here we will have two valves. So whenever train accidents happen and bogies derail, immediately we have to rip apart the bogies, because the bogies will not open. So they will always say in news, gas cutters have reached the site and they are cutting open the bogies. They cut it with this torch. Now this is very interesting reaction. You know, the torch will have two valves on it. The construction of the industry is such, that's the protocol of the industry. Flammable gases have a left-hand thread. Who is flammable out of them? Ethane is flammable. Oxygen is not flammable. Oxygen supports combustion. So C2H2. C2H2, how do we switch on gases? We switch on gases in this way. It will switch on gas in the opposite way. So first of all, he will open the ethane cylinder. Both will be open. He'll just open ethane and take the gas lighter and he will ignite the ethane. It will make a boop sound like this. You hardly will be able to see the flame, but you'll see a lot of soot, like Aladdin's jinn type of thing happening. It is burning. It is burning using which oxygen? Ambient oxygen. Is the ambient oxygen sufficient for it to burn? No, we heard it not sufficient. Now he will open the oxygen valve. Once he opens the oxygen valve, he will be getting what is known as some jet flame, like this blue colored flame. Complete combustion is taking place. But the complete combustion does not happen with the ambient oxygen. So he took the support of additional oxygen, and this process we call as lancing. And this tip will have so high temperature. And if you have got good artistic skills, I mean, I used to do this a lot. You can exactly cut things the way you want. Means you take big channels of what you call iron channels, and you want to create the pattern of a flower's petal. All you need to have is that your hand should be very steady and it will cut out. One way to drill a hole in iron is to use a drill. Another way is, if you have this, just put it, immense amount of heat, immense. Therefore, it is known as oxyacetylene gas welding, a part of your syllabus. What type of gas we use? Acetylene along with oxygen. Acetylene is ethane. It is a unsaturated hydrocarbon. Why do you need the oxygen? Because the ambient oxygen is not sufficient for complete combustion. Calorific value is very high, but for that it has to burn. The oxygen that you are getting is less. And once you give oxygen from outside, have you seen goldsmiths using a jet pipe and like that, and they're making the jewelry? So at that time they're using LPG and we are using more of air, lancing it. Have you seen people making corn, bhutta? So why do you do it? Or sometimes people using that, more oxygen, more air. Air contains more of oxygen. In fact, if you have you eaten the snack called the Haldiram Moong Dal, the Moong Dal snack? These are all fried in very high temperature. So if you go to the good halwais, they will always prefer diesel burners. Diesel burners have got diesel, and diesel comes in small droplets, and they will have another blower which is running. So the diesel is being lanced with oxygen, and then they will get huge temperature. Samosas always happen good, not at high flame, not at low flame, constant temperature. Diesel burners are excellent for making namkeens. Oxyacetylene. So what did we understand from here? We'll stop here, but with a little bit of discussion on combustion. All hydrocarbons undergo combustion to give you carbon dioxide and heat. In hydrocarbons, the alkanes will readily burn with the ambient oxygen, and therefore they are ready hand fuels. We don't use ethane for cooking. Nahi chahiye itna temperature. Our paneers will melt at this temperature. We don't want that. So alkanes are very good fuels. They burn readily in presence of ambient oxygen. And what is the proof of that? Blue flame. Whereas if I use alkenes or alkynes, I will get a sooty flame with orange color. And it will like this sort of sound it will make. But their calorific value is high. How to achieve it? Supply more oxygen.